Hello everyone. Today we're going to start section 15.3. It's double integrals in polar coordinates. Okay, let's get it started. Okay, so this is a lecture 16. Okay, we started section 15.3. It's called a double integral. In polar coordinate. Polar coordinates. Okay. Now, first of all, let's look at it. So-called polar rectangle. Okay, polar rectangle, we say it's a set of this form. Okay, so this is r theta, and r is between two constants, a and b, and theta is between two constant angle, alpha and beta. Okay, so if you look at the picture looks like this. Okay, we say suppose this is polar coordinates only have one axis, so this is called the polar axis. Okay, and this origin we call it pole, so this is pole. And then suppose this is alpha. Okay, if I say this angle is alpha, and this angle, okay, we said this angle is beta. And then, well, this curve, okay, this is r equal to a, okay, and this curve, okay, is the part of a circle. Okay, this is r equal to b, and then we said this is the region r. This is the region r. If you want to shade this one, okay, let's shade this. Okay, so that's called the polar rectangle. Okay, now when we consider, say here, integration, we say consider. Okay, consider this integral. Say if the integration region is r. Okay, say f x y dA. Okay, how do we integrate this? Okay, now we say we're going to do this. So here, let me draw this this picture again. Okay, so if I use the polar coordinate, okay, yeah, I think this is let me do a little bit better job. Okay, and then we say here is Okay, suppose we'll consider this region R. Okay, then we're going to do, say here, let's think about the 4 steps of a definite integral. First of all, we do partition. Okay, 2 variables, okay, partitions. So we have, say A is equal to R0 less than R1 less than R2 less than all the way to Rm. We call it B. Okay, so that means it's like this. So this is, suppose this is R0, R1, okay? And then if I say this is Ri minus 1, I think I'm going to put it Ri minus 1. And then here we say this is Ri. And then, well, here we call this one Rm, okay? And then on the angle variable, we do partition alpha equal to theta 0, less than theta 1, less than theta 2, less than, say, less than theta n. So this is equal to beta. Okay, now that's like this. So we say, well, this is the alpha, and this is a beta. And then we say, well, the angle, so this is like a, okay. And then we say, well, how about we say this is okay. We do partition like this. Okay, now let's look at this. So here, of course, we're going to say this patch. Okay. How about we say, well, this is this patch. I'm going to put it this one. This is called Rij. Okay, Rij. Now, if I separate this, okay, I'll just separate like this, and then, okay, if I enlarge this part, is here, this is Rij, okay, and then if you look at the center, so we say the center, so here we say center. We call it Ri star theta j star. Okay, that's a center. Now, of course, this Ri star is equal to 1/2 Ri minus 1 plus Ri, right? Okay, and then we said this is this is the center. Okay, so that's because this this curve. Okay, let me put it here. This curve is Ri minus 1, and this curve is Ri. Okay, of course, from the origin. Okay, this is the polar axis. From origin to the point on the circle, Rij, Ri minus 1, and Ri. So that's like this. Now, this is a partition. Remember, second part, we do approximation. Okay. When we do approximation, the function f, we say this f xi star, yj star, and then delta ai. Well, of course, delta ai is the area of Rij, the region Rij. We say delta ai is equal to area of Rij. Now, we know in polar coordinate. In polar coordinate, we have this. We have, say, xi star is equal to Ri star cosine theta j star. Yj star is equal to Ri star, and then sine theta j star. I think it more accurately we should use xij yij because it involve both I and j. So here's the ij, here's like that. And then, so we said this is equal to what? F of Ri star cosine theta j. You see, depends on both I and j. And then Ri star sine theta j. And the area of our say here delta ai. Let me write this separately. So here we say delta ai is equal to, that's the difference between two sectors. Okay, the large sector minus the smaller sector. The large sector is 1/2 Ri squared delta theta minus, well, you can say delta theta j, and minus 1/2 Ri minus 1 squared delta theta j. Okay, because here we say if you want to have this delta theta j is equal to say theta j minus theta j minus 1. So that's equal to that. Now you see here, if I factor the half and delta theta j, so we're going to have this is Ri plus Ri minus 1 times Ri minus Ri minus 1, and then times delta theta j. Now notice this. This is equal to Ri star. And then this one is equal to delta Ri. Okay, delta Ri. So that means this is equal to, okay, let me just put it here. We say is Ri star delta R and delta theta. Okay, so this is a approximation. Well, basically approximation, remember the integration, the geometric interpretation is the volume under the function fxy over the region. Okay, so we say, well, we still evaluate function at a point as the height, and the delta A, that's the area. Now just change everything in terms of polar coordinate. The meaning, the geometric meaning is still the same. Okay, so now third step, we do summation. Okay, summation. Summation, of course, we do here I change from 1 to m, and then j change from 1 to n. So we have f I star cosine theta j star. That's just an x ij. And r I star sine theta j star. Okay, and then this we need to have r I star delta r delta theta. Okay, or I star delta theta delta r, that's just the area. Right? Area times height, that's the volume. Okay, so this is a summation. And then we say part 4, we say take a limit. Okay, and then, well, how about let me just simply write it, limit. Okay, limit. Now limit, of course, we're going to put it like this. So here we say limit. Well, how about we say like your book, m, n, both goes to infinity. Okay, both goes to infinity. Okay, of this summation. Of this summation, we say I change from 1 to n, j这怎么搞的？What's going on? Okay, a little bit trouble. Okay, so here we have a F R R I star. This is cosine theta j star. Comma R I star sine theta j star. And then R I star okay, and then we have delta R delta theta. Okay, now remember this one, we say if you change this back to x xy, this, if the limit exists, remember this is this one. Okay, this is the f x y dA. Okay, so because this one is x I j, start. And this one is YIJ start. Okay, and this one is equal to delta A. Okay, that's equal to delta A. So this is if you change to x, y. On the other hand, we say on the other hand, we say this limit is, okay, so if you treat this as a function of r theta, okay, we say, wait, this, what's going on? This what's going on? I think that this is stopped. Okay, let me